The next talk is measuring quality of experience for short-form videos.
Thank you, everyone. Today we'll discuss about the topic of measuring the quality of experience for short-form video. So the short-form video are the one that you can see on a TikTok, on YouTube Short, and on Facebook Reel. The first question is, what do we mean? So I'm working at Whitby. I'm a Chief Operation Officer. And here what we will conduct is to see how we can measure it and what are the challenges and what are the impact. So the first thing is, how can we define quality of experience for the short-form videos? So here is a quotation. For me, a good TikTok application needs to be fast, smooth, so I can quickly swipe through my feed and watch video without any lag. At the same time, the video quality should be clear and sharp so I can see all the details of the content. This was a question about what is a good quality of experience. And as you can see, there is nothing about bitrate, packet loss, jitter, thing like that. It's really perceived as an end user. And this quotation has been provided by ChatGPT, which is an aggregation of the common knowledge and is a good way to see, okay, what you would reference as a good quality as a user. The question was really as a TikTok user or as a Facebook Reel user. The highlights in this is it should be fast because you are swiping through a lot of video. The transition in between should be smooth and without any lag while having a very clear and sharp video. And how the users are assessing this kind of video. It's fairly simple. So I'm sorry about the content of the video. It is what it is. I do not choose. So here you can see it's very fast when you do the swipe. You expect the swipe to be instantaneous. You expect to have a clear picture, even if it's more or less the same. And sometimes this can happen. And when this is happening, then you have lost the user. They will go out and do something else, maybe move from one application to the other, or you have lost the attention. And you can see what's happening on the screen here, and this is something that you may have experienced directly yourself. So what are the challenges around this kind of measurement? For the first thing, it's user-generated content. And that's the design of this type of application. So there is no way we can use a VMAF type algorithm, which are reference where you need the video before. You cannot guess what you are expecting. The video will keep changing. They are fully dynamic based on the content and the user, on what they have done before. So it's not possible to get the video before. Plus, a lot of people, like the one who are here today, are working to make it very smooth. So that means a lot of tricks are happening here. And because this kind of application, you control the source, you control the end, you control the player, you control the delivery, they are not bound by the standards. So they can do pretty much whatever they want, like prefetch, on-net and off-net cache. You know that Google is very keen on putting caches for YouTube video all over the networks to have caches very close to the users. They may or may not leverage HTTP2 or QUIC in order to really improve the user experience. And it's really open. There is no constraint. And as they can get creative, they will get creative. And it's changing a lot. Just for TikTok, since this year, there have been 14 releases just on iOS. And at the same time, Apple has pushed 5 different versions of iOS. So all being said, there is no way that we can build a predictive model based on what will happen on the device or on the network. If we were to try to assess based on packet loss, bitrate, TCP connection time, or logs directly coming from the player, from the device, there is a very good chance that by the time the model is accurate enough, then it's already outdated because it will have changed. They will have found a new way, a new thing. iOS will have released a new version of their player, and by that time it will be not accurate anymore. And it needs to be measured continuously because it's changing a lot and very frequently on various models, device, hardware, feature set, and components. So the approach here is quite simple. As there is no way to guess what's happening, let's just replace the end user. So here what you can see is this kind of device. So it's a bit bigger on the screen, but this is the size that we're talking about. And we plug a physical phone to it, and it's looking at the screen. And the metrics which are reported are by looking at the screen and evaluating and assessing the video quality and performance as an end user, without having to go into the device to get the logs, to get the bit rates or anything like that. So what kind of KPI are we focusing on? So when we work with various persons and groups in the industry, we find out that the main KPI for this kind of video are the following. First, we analyze the initial buffering time for the first reel that you will see. Here, users tend to accept a quite high initial buffering time. They accept to have 2 seconds to 5 seconds initial buffering time for the first video, because it's part of the launch time. You launch the application, it takes a few seconds to launch, so they are totally fine with 2-second video playback for the first one. But once this playback is done, they are very reluctant to have any kind of buffering. The expectation is 0 millisecond. You do the swipe, by the end of the swipe, by the end of the animation, you expect to have the first frame already available, and they will start complaining starting at 200 milliseconds of buffering time because this is what can be seen. And we have seen before that we have had some prefetch at some point. We have the first frame that appeared directly, but there was some buffering. And once it plays, they are very adverse to rebuffering. So once a video is starting, getting a rebuffering wheel or stop in the audio or video is has a very important impact on the perceived quality. For the video quality itself, the precision of the video, it's a bit less impacted, even if they are expecting a good quality. So most score between 1 and 5, even if they are between 3 and 4, they tend to consider that the viewing session was of good quality if the previous other statements were true. So here and in the article you can see some results about TikTok, YouTube, and also on Facebook Reel perform in various conditions. So a bit more on the video quality part. In order to assess it, we use our own algorithm, which is non-reference, real-time, without any a priori knowledge of the video parameters. So we don't have to know the codec, the bitrate, the resolution, and we really look at the screen, and from this screening mechanism, we assess the quality. So here, 2 examples. One with a very high quality, 4.7, and you can see a very fine detail zoom in to give you an idea. So we measure a block of 1%, a blur of 0.4%, which is very low and is a good indication of a very good quality. And at the bottom, just to give you a scale, content, which is null content with a very aggressive encoding, which leads to a MOS quality of 1.9, with blocks at 12% and blur at 60%. Blur, which is due to very aggressive encoding, low bit rate, and low resolution with upscaling at the player level. So that's for the video quality itself. Once the session is established, But already for the initial buffering time, one of the main topic, and because this is what the users really expressed, initial buffering time for the second and third and other reels. So here we are doing, the test pattern is we launch the application and we do 30 swipes. Here you can see something that try to look like a buffering wheel, which is not. On the other playback, we have other kind of buffering. So what you can see here is that visually, it's hard to tell. It's hard to tell what is a real buffering, what is a real stream which is frozen, what is good behavior, because it's very diverse. Sometimes you have black screen, sometimes you have buffering wheel, sometimes it's not happening, the sound can be happening. And due to the prefetch, you might have or not the next frame which is directly displayed. So like here, it's very fine and very smooth, and we can see that the quality is great. And on this one, something will not go as expected. So for example, on this one, this was a frozen picture, but clear enough, but still as a user, we can see our buffering. So having a good view of all these potential environmental situation and see what's happening in order to properly cluster them, qualify them, was very key to reach a precise measurement. We don't want to say there is a buffering whenever there is just a normal frozen still picture at the screen. And one last very interesting factor as well is this kind of application are used a lot in mobility. So what are the effects of the radio environment toward the application? So the radio can change thanks to the various optimization. It can or may not, it may or may not affect the perceived quality. So here we are reporting at the same time what was the radio conditions as seen by the smartphone, and at the same time what were the video conditions as seen by the user. And we correlate the two of them to see, here we can see a buffering event that lasted 2 seconds when we had a poor radio event. And after, once the radio reached a certain level, then the video was being able to buffer again and stream again. So it can be used in real environment because it's real phones, real application with a real 4G, 5G stack or anything that you can get as a user. But it can also be used in control environment. So some of these deployments are done in radio control chamber in order to mimic application like I will drive in a highway with a lot of cells being back and forth. So it's not something that we control, but in the industry, a lot of our partners or customers have this ability of fully managing the radio environment. So seeing how the video is being affected while controlling all these parameters is very interesting for improvement. And as a change, something, for example, activate or deactivate on net caches, or try to fine-tune the various radio parameter, they can see what the effect is on the real applications. Thank you for your attention. So just one word about the company. Everything that we do is test and monitoring using real devices. So from the smartphone to the smart TV, including all the real set-top boxes, OTT boxes in 4K. And I will be happy to discuss more about that during the break. But meanwhile, if you have any question, I would be happy to answer them.
So possibly just one quick question. Anybody? Yeah, okay, come here.
So for the QoE, you mentioned that you have one no reference measurement for the video quality rates, and this is your own and proprietary metric. Have you published any results on that, like or any blog post can we see the accuracy correlations with the subjective data sets and so on and so forth?
Yes, we do have some publication on our website. So we did a set of what we call the snapshots, which we are measuring the video quality over various environments, like for the Super Bowl, for example, and across different technology.
Okay.
So it's available and publicly available.
Okay. Yep. Thank you.
Okay, great. Thank you very much again.
Thank you.